Welcome to the DIY Honda Garage channel. This presentation addresses DTC Diagnostic Trouble Code P011A, which indicates an ECT Sensor 1 circuit range performance problem in the Honda CRV models from 2017 to 2022. The ECT, or Engine Coolant Temperature Sensor, plays a crucial role in regulating engine performance by providing vital temperature information to the Powertrain Control Module, PCM. When the ECT sensor malfunctions, it can lead to poor engine performance, increased fuel consumption, and potential engine overheating. Understanding the specific components involved and their locations in the vehicle will be vital as we proceed through the diagnostic steps. Your ability to accurately diagnose and resolve this issue will culminate in optimal vehicle performance. The DTC P011A refers specifically to the Engine Coolant Temperature ECT Sensor 1, which measures the temperature of the engine coolant. This is critical for the engine management system as it helps in calculating the fuel mixture and timing adjustments necessary for optimal engine operation. The ECT Sensor 1 is typically located near the engine block, where it can accurately gauge the temperature of the coolant circulating through the engine. Its readings directly affect the Powertrain Control Module, PCM, which uses this data to optimize engine performance and emissions. Furthermore, any malfunction in this sensor can lead to degraded engine performance, making it imperative to address issues identified by this diagnostic code timely. Several potential causes can lead to the P011A error. First, there may be poor connections at the ECT sensor or associated wiring harnesses, leading to intermittent signals or disrupted communication with the PCM. Loose terminals are another likely culprit. They can prevent secure electrical contact, resulting in erratic sensor behavior. Lastly, the ECT sensor itself may be faulty. A malfunctioning sensor could provide incorrect readings or fail entirely. It's also essential to consider the condition of wiring and connectors associated with the mass airflow (MAF) sensor and intake air temperature (IAT) sensor, as any issues in these circuits could potentially influence ECT functionality. The symptoms associated with DTC P011A may include a check engine light illuminated on the dashboard, alerting the driver to a potential issue. You may also notice poor engine performance. This may manifest as rough idling or sluggish acceleration due to improper fuel mixture adjustments. Increased fuel consumption is another critical symptom, which may lead to higher operational costs as the engine struggles to maintain efficiency. Additionally, in severe cases of sensor malfunction, the engine may overheat, risking more significant damage. Drivers should remain vigilant for these indications and address them promptly. The first troubleshooting step involves a visual inspection of the connectors associated with ECT Sensor 1, ECT Sensor 2, and the MAF and IAT sensors. Poor connections and loose terminals may often lead to performance issues, so it's vital to ensure all electrical connections are secure and free from corrosion or damage. Physically examine the wiring and connectors to identify any signs of wear or disconnection. If you observe any issues, you should address them before moving on to further diagnostics. Ensuring a sound electrical connection is a fundamental step in troubleshooting, as it lays the groundwork for accurate sensor functionality. After completing the visual inspection, check if the connections and terminals are satisfactorily secured. If you ascertain that the connections are indeed secure, the next course of action would be to replace ECT Sensor 1, as it is potentially malfunctioning. On the other hand, if you find any issues, such as poor connections or loose terminals, then the immediate action should be to repair these faults first. Ensuring good electrical connectivity is critical to restoring proper functionality to the ECT sensor. Once any necessary repairs have been made, rerun diagnostics to see if the code persists, affirming that you've effectively resolved the underlying issue. Once repairs have been completed, the final verification step is to clear any stored diagnostic trouble codes, DTCs, using an OBD2 scanner. This action resets the system and allows for accurate monitoring of the vehicle post-repair. Following this, conduct a road test to observe how the vehicle performs under various conditions. During the road test, pay attention to the engine's behavior and ensure that the check engine light does not illuminate again. Confirming that your vehicle returns to optimal performance, including stable idling and responsiveness during acceleration, is crucial before concluding that the issue has been resolved. To prevent reoccurrence of the P011A DTC, it is advisable to implement regular maintenance practices. Periodically inspecting electrical connectors and terminals can help catch potential issues before they escalate into serious problems. Additionally, keeping an eye on engine performance and watching for symptoms like fluctuations in idle speed or increased fuel consumption can signal the need for further diagnostics. Scheduling routine OBD diagnostic scans can help identify fault codes early. By proactively monitoring these systems, you can maintain the integrity and efficiency of your Honda CRV. In conclusion, addressing DTC P011A is essential for maintaining the overall health of your Honda CRV. The engine coolant temperature sensor plays a significant role in ensuring optimum engine performance, and identifying any issues early can save you from costly repairs down the line. Understanding potential causes, symptoms, and effective troubleshooting steps lays the groundwork for efficient diagnostics. Regular preventive maintenance is key to ensuring your vehicle runs smoothly while minimizing the chances of future errors. This comprehensive approach will allow you to safeguard not just the performance, but also the longevity of your vehicle. Please like and subscribe to the channel. See you next time.